Welcome to this info video tutorial. We will cover in this video the product DTMaster and the DTM Workflow. In a previous video we calculated with matcht DSM a DTM and a DSM, and both of these two products that we calculated, they generated a point cloud. Let's just shortly take a look how they looked like. So here are the two results from the previous video. We generated a DTM, and here we have as a result the .dtm.las file, which is a terrain point cloud for the complete project. And we have the folder DSM, where we have multiple las files because it's a very dense point cloud, and it's tiled into multiple result files which also cover the complete area. In info we are focusing different results with a DTM run and a DSM run, and therefore we need different ways of editing with these different results. Hopefully the video will cover enough for you to follow the workflows. Still, we will split it into two videos. The first one will only focus on the DTM, and in the second video we will then focus on the DSM workflow. We will show a typical short example for each of the two workflows. Independent from the two workflows, there are two major similarities that we really need to be aware. Perhaps the most important one is, it's really a myth that the result coming from any terrain extraction software is ready and steady for continuation in any production chain. We will always need editing, and therefore the result, in our case from our software matcht DSM, is not a final product. It's a work in process point cloud, and at this stage of the workflow we really have to be aware that we need the editing. And therefore the second important part is, terrain editing is the most time-consuming human act in the whole workflow chain, and it will always need human interpretation and a good sense of quality assurance and quality control. Which means, for example, if your data is only capable of reaching 10 centimeter height accuracy, then it does not make such much sense to target a final terrain model with 30 centimeter or better height accuracy. And this has nothing to do with lack of effort. It's really just pure statistics. And the noise ratio in the data cannot be eliminated just through manual work attitude. So therefore, common sense in reaching a specific height accuracy is very important also here. Okay, so let's start with the DTM dataset, and we will start DTMaster. We start DTMaster from capture DTMaster. DTMaster is a standalone terrain editing software, and we need always to import the data into the editor, so it's no direct connection to any CAD software. For the DTM workflow, in general, the data sets created by DTM are not very large, and therefore we can directly import the complete DTM into DTMaster. We will always follow a standard routine for the terrain data editing. First, we search for errors with given relevant information. Second, we make an interpretation of the situation. Third, we select the wrong data. Fourth, we make a correction of the error. And finally, we do an on-the-fly check and see that the correction that we have done results in a correct representation now of this area. We will do this with specific parts of our data, so let's import our DTM. We can do this by File, Import, Quick Load Vector Data. We go to DTM Video and we select our LAS file. It's a metric project and we imported the data into DTMaster. Let's start to search for errors with relevant information, and therefore in DTMaster typically we use the different display options. I will switch off the display of the points, and one relevant information are the contour lines, which can be activated here. We can change the contour interval here through a drop-down list where we can directly look at 1 meter contour lines or at 5 meter contour lines, or we can make a user-defined contour interval and define here a value and say we want to have 7 meter contour intervals or whatever we need. A second option instead of contour lines is the shaded relief, where we simulate a sun reflection on this terrain and we see where height changes appear. Additionally to the shaded relief we can also add a Z coding, which gives the shaded relief also a height coloring for height changes. Typically people use contour lines as they give us a numeric value for our height changes. So typically when contour lines pile up very steep close to each other, we can directly see that we have here a terrain that is not typically looking made by nature but by human. I will zoom here into an area, increase the contours to 5, and we can exactly see here how these contour lines pile up here. We have here 5, 10, 15, 20 meter height change from this area to this area here, or as mentioned also we can use the shaded relief together with the Z coding, and we also see here how this terrain changes unnaturally. The interpretation of the situation is the most difficult part in editing, and therefore we try to give additional tools and views. So one view is the profile view, which we can select either here or you can go to view profile area and you make 2 clicks, and after you made the second click and you move the mouse, then you open up a box, and then I move the box and I click a third time, and wherever I click the content inside the box is now opened in the profile view. We can see here this red line at the bottom, which represents this red line here. So currently we are looking from this left side into this box here inside. So this is our current view. If we keep the right mouse button pressed and we move it left and right, we can rotate this view and we can see the data from a different angle. I can also move it up and down, and then we look from a steeper part to the data, always having this red line here indicating where we still have our left and right side of the box. We can change the height of the box here by stretching it to a 1:1 scale. So now the height and the width are equally scaled. If it's automatic, we use the maximum stretching of our current profile view. In the profile view we can also use shaded relief view. We can also here Z-code it, remove the points, if this helps us to give a different interpretation part. Another option to display the data is in stereo. If you have aerial images with orientation, you can use here the best fit stereo, or again here select from the view the best fit stereo, and then you just click into the area you want to see. To make this function work, you have to go to photos and activate all photos. So you select them and you select active, and when they are active and you click into a situation, it will use 2 aerial images that are displaying this area here. And if I zoom out, I have now the advantage, I see my point cloud, but I also see the image content. So if I display only the contour lines, then I see now my contour lines piling up at this building here. The interpretation is the easiest here because I can see the content of the image additionally with the contour lines of my point cloud. For the DTM editing, typically people tend to work mostly with the profile. It's faster than with the stereo first. Only when the interpretation is not clear, we will see later on, then we can go to the stereo view, which gives us much better interpretation. So next step is selecting the wrong data, and we will use here the point selection tools. Mostly you will work with rectangular or with the fence selection. With rectangular, I just drag a box and everything in this box is selected. If you want to unselect the points, you can hit the escape on your keyboard. Or if you select the fence selection, then I can now here generate a polygon, and when I double click at the end, all the points inside the polygon are selected. If I want to deselect points because I selected wrong ones, you keep the control button pressed, you make a fence, and when I double click now, when I have my control button kept pressed, then they are deselected. When my wrong data is completely surrounded by correct data, so everything around my data here is correct, then I can use the function Reinterpolate, and it will use all the selected red points, and each red point will get a new height interpolated from the surrounding points not selected. So if I hit this, all my points drop down, not on one height, but they are interpolated into a specific height. If I remove my selection or undo my step, and I select a second time now here my points, let's deselect them here, and now I will just deselect here one point in the top, or a few here. So we have now most of the points selected, but here a few points in the center I not selected them correctly. If I hit now the Reinterpolate, then we see also points inside the data which is not selected will have an impact on our interpolation. So be careful, select correctly, and then you can easily manipulate a large amount of data very quickly, correctly. But of course, if you have a few wrong points, then this can cause conflicts. In general, the reinterpolation function is the most used function in the DTM editing, and therefore most people really use them to make a correction. So in my case, when I reinterpolate, then my final step is now my quality assurance. I check now, is this now correct? I look at it directly. It's what you see is what you get. So in my case, now the data is on the ground, and therefore I fixed the problem. I fixed the error in this area. Another big advantage of reinterpolating is that the points are still in the same density. They still have the same location. Because some people, they also just delete the points. So I can also delete the points. Again, my situation is cleared. I have no wrong points, but I still have now a gap. And if you have a gap, then this can cause later on in the orthophoto production for black holes. And to fix these holes here, you can use then a function here which is called an Interpolate Gap. And this function here needs to have the correct layer where these new placed points are introduced. So I will make them into ground synthetic, and you need to define the grid spacing. So you need to know how dense is your DTM generated here. If you are not sure, you can use also here a measurement tool and check here what is the distance from this point to here. So in our case it's a 2 meter DTM, and therefore we can fill this gap here or interpolate a gap with a 2 meter grid. We digitize here a polygon around it, and then it will interpolate points into this gap with 2-meter distance. And if we look here at the data, it looks similar like our other data here. It's of course overlaying, so we have at some parts not anymore a 2-meter distance, but don't forget, this is not our final result. This is now our work in process point cloud, and from this one we will later on export a final result, which will be our terrain model. If we undo these steps here, another workflow that people use is also classification, but this is not so typical in the DTM extraction. So we select here the wrong points, and they move them into the correct class. They would say this is a building. So the selected points are correct, my layer is correct, and then I can hit the classify selection, and then these points move to a different layer. If we go to the terrain tab, we have here with the LAS file our standard classes from the LAS file, and if I look here at building, then these points now are here inside of the building layer. And when I remove the display, then we see here the points are away, but they are still used for the interpretation of the contours, which is handled by this interpolation flag. So with the interpolation flag, the data is gone, not visible, but used for interpolation. Very important later on when we generate our final result for SCOP DTM, then we also need to check which layers are activated for interpolation. And then of course it would be the same. I can now here again use the gap filling function. Instead of using the manual one, we can also use the automatic one. In the automatic one, we define here the grid spacing, and it will automatically search for gaps larger than 2 meters. And when it finds this one, it fills them with a 2-meter grid. It still keeps here a short spacing so that we see that there is my original data, and here it starts my synthetic generated points. They are not matched, and so we have again here our terrain correctly filled. So from here on, it's really just a work process. We use in the main view our contour lines. We search in our contour lines for errors. When we detect an error, we can use different displaying options. In the displaying options, we can now again select the wrong points. We can use the plus minus buttons of the keyboard to enhance this one here. We select then our fence selection or rectangle selection. As mentioned, most people use the reinterpolate function. So I use then here reinterpolate. The points are placed on the ground. I check the result if this is fine. When I'm fine, again, then I search for the next part and continue this part. DTM extraction is very good for open terrain or for areas with not so much close buildings. For example, we have here this hill part. So if we go to this hill part here, we can see here the hill was well extracted. We still have here our wrong points, and therefore we can here also select here the wrong heights by using the profile, the fence selection tool. So we can go here along the profile of this mountain here, select it, rotate the view, see if the correct selection was done, use the reinterpolate functionality, see if this now created a good terrain model for us. We see some parts are not correct because they continue, so we can use the pan function by hitting control button and right mouse button. We can continue to the next part here. Again, select the points now here. Again, use the reinterpolate function. Again, move to the next part here. and so we can continue our workflow. This is the main workflow for the DTM editing, but we will face, of course, our limitations, mainly here in city areas. Let's take this block part here, where we see, for example, here that we have some sort of buildings and some sort of street areas, but sometimes we cannot really see the street to the bottom, and therefore DTM generation is not the best solution for dense area or city areas. We recommend for city areas the DSM workflow, and I will show here for this part how we can easily get the city area here, the terrain model. You can also do it here, but you will need a lot of manual editing, and therefore time-wise you will face a big issue. Some people they use a very rough method. They would, in this case here, even just use the fence selection tool. And delete the points. And then in this part then here we can then use the fill gap functionality to continue the work. So we can here select the whole city part, because it's a flat area. And then we have here a very rough terrain model only, representing the terrain part here of our city. But of course we lose small structures, we lose parts that are perhaps important for us, like if we have a garage where we have a driveway going downwards, we would lose these parts here very easily. And therefore the DSM extraction with filtering and then extracting the terrain model with more details is a much better solution than to give a more detailed terrain model. Let's just sum up. We search for errors, we make an interpretation of the situation, we select the wrong points, then we correct them, and we need to do this systematically. So you can either here go just from west to east or from north to south through your data and pick your wrong data, and hopefully at the end, after the manual editing, your data is correctly on the ground. And then we see here the data correctly in our DTMaster, and then we can export the data as a final product, and this can be done by going to File, Export, Raster. Then we select our output name, and then in this case here I call it here Final Edited DTM. And we see that the format is called a SCOP DTM file, which is the format we live in Info. So Info lives with SCOP DTM formats in its complete workflow chain, and we will use it for orthophoto production in DTMaster, and also for SCOP++. This is the format. And then we define our raster spacing. Of course, we will stick with the 2 meters. And you remember I filled the gap with points, and then the redundancy was stronger at some parts. I had points closer than 2 meters. But even if I would have smaller gaps, then this raster spacing here is interpolated from the given data here, and it will generate equally spreaded 2 meter DTM with my corrected data. So everything I see here now will now be used for the generation of my scope DTM, and my final result is now here in the DTM final. This is now my final scope DTM with 2 meters, including all the edited parts. Let's take here a final look at this one here. We will kick this one out here and import the final extracted point. Sorry, here DTM, final DTM. And now when we look here at this area, we can see here now the corrected part here that we generated here is now showing my edited solution, and also the buildings that I eliminated here. I hope this helps you to work with the DTM, and in the next video we will show the workflow, a typical workflow with the DSM data, which will use the filtering functions to automatically first classify points into ground and off ground, which is of course for the city part here in the upper part important, and will make work easier to extract a correct DTM. Thank you very much for watching this video tutorial.